so I was originally going to wait until next weekend, but I decided, because I talked about categories so much, and I showed you the protocol one already, let's just go ahead and do this category tutorial. Plus, it's more entertaining than listening to me talk about other stuff anyway. So this one is called Reverse a String. It is in the bhacker.com directory under, and it says category next to it. It says Reverse String Category Tutorial. Just for those people who don't have equipment with you, but maybe want to do this later on. It is in the source code examples folder of our class. So it's not way down the list. We skipped a lot of other stuff. So next time we'll do all that other stuff. But I figured we're on topic, so I might as well finish with categories because I already gave you some of the stuff on it. And I didn't want to have you leave with the impression that a category was only used for static methods. It's used whenever you want to add functionality to your class. So what we're going to do, and to your object, without actually putting it in the object, we're just going to add stuff to the object. And I'll show you another example with more source code next time, but I just want to show you this one because this one's actually kind of a fun reverse a string kind of iOS tutorial. Why do we want to convert data? Sometimes you want to perform some task on some object, and it's not included in the methods of that class or that object. You just want to do it with the object, but it's not part of the concept of the object. Like a string as an example. To reverse a string, we actually probably could have put it in there, but we don't have to. So an example of this might be to reverse the order of characters in an NSString object. While you could certainly put it in the code itself, it would be better to add it to a class method. So this is a class method. To the NSString itself, that would reverse any string. So we're going to supplement it to NSString. We're going to add a method to a built-in class using this category. So categories, don't get the impression that they're only used for one purpose. Multiple ways of doing stuff with this thing. So it's kind of multi-purpose. I'm going to show you a totally different way of doing it next time, but we'll just look at this one for right now. We use a category to add a string reversal method to a NSString class. So here's your textbook definition of what a category is. So a category is an object of C construct. It's not an object, it's not a class, it's not a protocol. It allows you to add methods to any class regardless of whether or not you had the source code for that class. You don't need the source code. We don't have the source code for NSString, but we're going to add a method to NSString. Class method to NSString, and we're going to call the method outside of NSString and use it as a generic method that we're going to use to perform this reversal of the string. So once you add the class, all of the methods in the category are added to the instances of the class in your code. Everybody's got access to it. Everybody can run it. And since they're maintained in separate files, it's simply a matter of including them into your project. As I mentioned before, you make a big old repository of these categories and you just add them to your projects. Once you make it one time, you just reuse it all over again. You supplement the behavior, just add new stuff into it. So you include it in your project where the extended features of the class are desired, where you want to use it. So let's go ahead and build one, and then we'll add, and then I chose to do it with an iOS app because it's more interesting. However, you can do this with a non-iOS, and the example I'm going to show you next time is going to be a non-iOS. So open up Xcode. If you have Xcode, open up Xcode, create a new project. Do this at home if you don't have it with you today. So under the iOS, I'm going to click on Application. And I'm going to click on a Single View Application, same thing as I did last time. Next time, we'll do some more options. We'll use the empty one. Actually, I'd like to use the core data, which is actually kind of an interesting one. So we probably won't do any OpenGL. It takes too much time. It's kind of way off target for this class, but we will experiment with other ones. So I'm going to call this a string reverse. Doesn't really matter what I call it. I'm just going to throw it away when I'm all done with it. And I'll do it for the iPhone. And I'll go ahead and press on Next. And save it to my desktop. So I have my project created. And first thing I'm going to do is build the interface, because I like building the interface first. I'm going to click on the storyboard. We did this yesterday. And I usually always move it over here. So what am I going to do here? After I've done all that stuff, I'm going to add a UI text field and a UI label. We did this yesterday. So we're going to create a UI that looks like that. So, because we're going to put a string in here, press return, and have it reversed. And we're going to use a category to do the reversal function for us. So let me build up my interface. Let's see. I always put a green background on everything, so there's my green background. Let's see, I want a text field. UI text field. Got one right here. And I could spend all day playing around with the interface, but I won't. I'll make the text a little bit bigger. 17, 18 looks good. Perfect. All right, and then I'm going to put a label underneath it. So, label. And I'm going to stretch the label out here. And I made this guy here 18, I think. Font size 17, so I think I'm going to put him into 17 as well. I have to get it up on 17 already. Okay, good. Take label out of here so it's actually there, but I can't see it. So I'm going to get rid of the side panel, and I'm going to put up my little tuxedo. I'm going to make some properties out of these. Property and synthesize, we just went over it. So I'm going to click over to the .h file, and on the .h, I'm going to make some space in between my @interface and @end. And notice I'm not inherited from NSObject. I'm on UI view controller because I'm inheriting from a view controller component, not NSObject. A little lower down the hierarchy. So I got this selected already, so I'm going to pressing down the control button, I'm going to drag it down here, and I believe I'm going to call it the label, or what am I going to call it? I'm going to do a couple more things to it. Let's see. Doesn't really matter what I call it. Let me go back up to the top, maybe I mentioned it. I'll just make up some names, it doesn't really matter. So let me just make up some names. I'm going to call this one output, outtext, outtext and in-text. That way I can remember what I'm looking at. Outtext is a UI label weak. Looks pretty good to me. I'll leave that one alone. This guy here is going to be in-text. So input. Did I put out? I put out, so I'll go in. In-text and out-text. Pretty good. So I got my two properties. And then I can flip over before I forget. It doesn't really matter what order you do this in. And right after the implementation, come down here and I'm going to put synthesize in text, comma, out text. There we go. I like to do these one after the other so I don't forget. If you forget to synthesize, you don't get the setters and the getters automatically. You just get this property and it doesn't work. So I believe, well, I haven't tested it yet, but I believe they took it out as a requirement, so you may not have to synthesize anymore. Because if you think about it, why do you have to synthesize a property? Just make a property and it should automatically synthesize. So you may not actually have to do that anymore. So we'll see. I have yet to try it out. I'll have to try it out. The only problem with iOS and the whole kind of way that they've grown through this is that every new edition of Xcode has new rules and new features and everything keeps changing. So. But life's about change. So in the attribute inspector for the UI text field, I'm going to set the return button type to done. Because when I'm done and I press the return, when I press the return key, if I set the type to done, it sends to the observer a done signal. It tells me I'm done typing. And if I'm done typing, the keyboard will go away. Otherwise, the keyboard will stay up there. So I set the return button type to done. I'm going to go up there and let's see. And in the attribute, we have the fourth button to the right, and then we have the return key is towards the bottom of its setting selector. Well, let's see if that's still the case. So I'm putting this back here. This is what they call the attribute inspector. And on the attribute inspector for this one here is what I want. So I clicked on the text field. And let me make this a little bit bigger so you can see it. Down here on the bottom, I have something called return key. And this one's going to be done. And done's on the bottom. So return key does a done. And then, let's see if there's anything else I want to set here. No, it looks pretty good to me. Okay, looks pretty good. So on my done, okay, very good. Good. Appearance is, what would the appearance would do? Yeah, we'll leave the appearance alone. Okay, so we have the return key towards the bottom, and that was what we set to done. Okay, so now we're going to add the category. So I'm going to go, this is the screen we just looked at actually. So we're going to add a category, and we're going to call the category, we're going to name the category added methods. And I'm going to see when I create it, I'm going to get a .h and a .m, because I'm going to write the method, but I'm doing it outside of all my other objects so that I can reuse this in the future. So make sure the category is on NSString, that we're inheriting from NSString, because we're going to make a special type of NSString. We're going to call it added methods. So let's see. I'm going to get rid of the side piece. Actually come back to here. Come up here, go File, New, File. I'm in the Coca. See now, down here I'm on iOS. That's my complaint. I don't like it, the fact that it's down here again on OS X. I'm going to go back up here, press it, Coca Touch. I want Objective-C category. Click on Next, and it says NSObject. Everything by default is supposed to say NSObject until you change it. If I put it on NSString, the sucker will probably say NSString next time I use it. So, added methods. And change this one to NSString. If you just start typing it, it will usually find it. There you go, NSString. So, category on, isn't this kind of the same concept of inheritance? So, it's not an inherited class from NSString, but it is. We're going to take NSString as the base, and we're going to add methods to it. And the added methods are going to be in this category, which is why I called it added methods. And reinforce the point. So if I say OK and I press create, now I get this interesting looking syntax over here. And it says NSString plus added methods. Which means we're not overwriting anything, we're not overloading anything, we're not even inheriting anything. Instead, we're just going to supplement without touching it, which is kind of a different, unique concept. It only exists really in Objective-C. I haven't seen it in any other language, really. So this is how we use a protocol. So NSString added methods, category. So if we look at the implementation of this, I have a .h and I have a .m. The .h has got my interface and my .m has got my implementation, and I look at this and I go, well, isn't this kind of like a method? I mean, isn't this just kind of like any other class I've already worked with? It is, except for the class name is NSString. The category is added methods. We can use built-in categories with the same component. I'm going to show you one when I'm all done that uses a math, that adds math functionality. It's in code 3, actually, if you want to look, or 4, actually, if you want to look ahead on it. But long story short, this is the syntax for using the protocol. We define it inside of the protocol. Category inside of the category. This is a category. All right, back to my instructions. Hello. So we click on the next when we create it. We have these two files. These two files you just saw live, actually. These files name and convention. It's easy to see categories that we've added. So NSString plus these added methods. Why I did it this way, I have no idea. Well, it's kind of explicitly saying that you've added this to NSString. So if you open it up, you see that you've added, and we want to add now into the interface. We're going to add the prototype for the method that we're going to add. And we're going to add a declaration for our new class method as shown below. So we're using a class method, not a instance method, because we got a plus on the end. And the method is going to return an NSString. And if I can copy this. I'm going to open up my thing here. Just like any other class, the only thing different is that I have a plus in here now. I'm putting a class method in here. We can put instance methods in here, but how are we going to use that? You're going to see, yeah?
We won't be able to use them in the other classes.
Yeah, no. Well, you can add the protocol to anything you want. You can use the protocol in anything. Excuse me, the category. You can use the category in anything you want. You can reuse it all over the place.
So we need not to include it.
Yeah, it's not included. Well, let me back up for a second here. We're supplementing, in this particular case, we're supplementing methods that don't exist in NSString. We're adding some stuff. We're building on NSString as an object, and we're just going to add some more stuff
so we
to
can
that
synthesize
object.
it. We have to synthesize, we can use it, right?
No, we're going to see in a few minutes how we're going to use it. But it's as if it's now part of NSString. We're just going to use the method just like it's a method. We don't have to do anything.
Method of NS object.
It's NSString.
Yeah, NSString.
It's a method now that belongs to NSString.
Will it be referred elsewhere without implementing? Or without
Correct.
implementing?
You don't have to implement it. If I've implemented in here and I inherit another class on top of this other project and I put more stuff in here, it all belongs to the same hierarchy. I'm all inheriting it together. It's all part of the same picture. I don't have to add it in again. I only have to add it in one time. And it becomes part of the class implementation. Without this inside of the project, there's no visibility to it. I don't see it. All I do is add the file, add the object to the project. Use it inside of the project.
If I want to use this thing in another project,
Then you just add it to your next project. You save it.
we need
Put
to
it in
add
a-
this entire project into another project or only this file?
You would, if you wanted to use this elsewhere after we're done with it, you copy these two in a central location, and then drag them into the new project. Add them to new projects. Reuse them. Because this is kind of like the way of creating generic functions, utilities, functions. The math categories are done this way.
What is the use of adding it to the base object? You can add it to a normal custom object. Right?
You can add it to a custom object, yeah. You don't have to. This is a base object. You're right. We can add it to our custom objects. We can add it to any object we want.
I don't see anything
Yeah.
advantage.
There isn't. It's just we had to pick something to add it to. Let's add it to NSString because we're going to use a string. It belongs to the string class. We're going to make a string object. Might as well add it to a string object. This functionality doesn't exist. But there's no string. There's no method that says string by reversing a string. Inside of that string and a string, we're just going to add it right now. So we're supplementing it by adding this functionality, and it happens to be a class method. So don't worry.
And what if we create an instance level? We can declare it, right? It won't stop us from declaring an instance level method.
We can use it with an instance. The instances can use it. It's part of the NSString now. Just like any instance can use NSString.
No, I'm saying if we declare another instance level method, like with the minus sign, if we declare a method.
Ah, that's what I was going to say. There's no purpose in doing that because what instance are we going to use it in NSString? So if we use an NSString, create an instance of it. It's like the difference between using a class level versus an instance level. We'd have to make an instance of the object to use it. Here we use it at the class level. If we say NSString, my string, reverse me, that's a class level. We're going to see it then when we use it, and I think the light bulb is going to click on for you with that. So, but the point I was trying to make was that this is a class level method. First time we've seen one. So before, up until now, we've only seen instance methods that belong to instances of objects that we create. This one's going to belong to the NSString class because it's not inherited, but it's added to as a category to the NSString. So work with it in terms of the concept, and you're going to see it come together in a few minutes. Save the file. I'll save it in a few minutes. Now here is the method implementation. I'm just going to copy this out of here. Let's see what happens. I believe I'm missing a closing bracket here, but let's just see what happens. And then I'll go through the explanation of what the code is actually doing in a few minutes. So I'm going to save this guy and go into the M and implement it because I added the interface in the .h, and here's the .m implementation. And I need to get rid of some special characters, and I need to add a closing bracket to the end. Get rid of some pasting errors. There we go. So this is why I saved this for the next time around, but I'll go through it now because you guys, this is your first exposure so, to Objective-C, and I'm going to go show you Objective-C code. But it's actually not too bad. We've seen all this stuff already. This is regular old C string character array of 50 characters. And we have the starting string, and then we're going to have the reverse string. That's also going to be character array. And then we're going to have an NS string object that we created, just like any NS string we've seen so far today. And then we're on the string. We're going to use a get C string with a maximum length of the string with the length of the bytes using the encoding. So we need to encode it to a string compatible array. Just take that with a grain of salt for right now. I'll come back to it in a few. Print out to C string. It's kind of because C string is compatible with this UTF-8 string encoding that we're using here. We're using a string encoding built-in method to convert a character C string into a string that's compatible with a Objective-C string as a data type. And we can print it to itself. So we can print it to the screen, and then we say, for I is equal to 0, I is less than the length of this string. Take this one here and put it in the reverse order. So we're going to reverse the string, and then we're going to copy the string to another string. We don't need a space there. Put a, we're going to strip out the first character, the last character is going to be the null character because we're creating a string. So we're going to take a string from the text field, turn it into a C string, go through a loop with the first character, second character, third character, put it into another C string array in the reverse order, slap a string null character at the end of it to turn it into a string, and then copy it into a string from a C string. This is essentially what we're doing here. So this is the return value. The return value is going to be a NS string, because we need to take the return value to copy it to the label, because the label wants an NS string. Or we can probably, well, it's better to return the string, because we could return the characters, the C string, and then convert it out over there, but we can take care of all that stuff in here. So, which is essentially what the method is doing, but you don't even have to worry about the method. Just know that the method is reversing the string for us. So, and the method's in the category that we're using. So if I come back up here, this is the explanation from a textbook perspective. Much easier to index a C string, build them up in character by character, because we don't actually have an NS string object reverse, but you can do it easily by using a character array with a C string, which is compatible. So in this method, we set up two character arrays, as I mentioned before. I get the C string representation of the str argument of the string, copy it in by the maximum length of the string, figure out how big the string is, go in the reverse order, take the maximum length and decrement it from 10 to 1 or whatever, 10 to 0. And then put the null character at the end to turn it into a string again. And then copy the string into a NS string, and this NS string is called return value. So let's see. We're going to add to the viewController.h. So this is how we're actually going to use this category. We've copied it into the project. Now we need to tell the existing classes that they're going to use it. The class that's going to use it is going to be the viewController object that controls the view. We go back to this morning's model viewController. That's the object that we're getting here. So we're going to import this guy. So same thing that we did with the person and the employee and all of the other classes that we used inside a main, because this is really, in essence, our main, if you want to think about it. So I'm going to save this here. Don't really have to save it, but it helps with the error messages that come out because it hasn't been created. So viewController.h on the top, here on the top, I'm going to import in and use my NS string, or excuse me, my NS string plus added methods, my category. Say that correctly. All right. Wire the buttons. We already wired the buttons. We got an output. We got an input. Input done. Oh, I didn't wire the input done on the UI text field. Let me show you something else we can do as well. And this is another little trick that you can do to create a little event-driven behavior for the input field. If we don't want to trust, and this was the old method, that return key done should do it for us. But if we're paranoid, we don't want to trust that. And we don't want to use that property. We want to use, let me show you another property. It can also be used. So if I click on the little text, let me get rid of this one here for a second. Click on the little tuxedo item here. I have the two properties. I can also create an action that works with this. So if I right mouse click on this little guy here, I've got an exit, did end on exit method. So I can resign the first responder, which is going to be the keyboard, which is really what the done is going to do. So if I drag this guy over here, and I can just say finished, because I ended, and press return. When I press return, it's going to send done. But I want to have something else happen here, and the type of this guy is a text, UI text field. I can have left it on ID, it's okay. But now I have finished. Finish is the action of when I press return, it's going to be sending this did end on exit. So just take that with a grain of salt. If I move over to the .m implementation, I see on the bottom I've got the finish method. In the finish method, it's very common to see the resigning of the first responder, which is their send to resign first responder. So if you have an observer, he's kind of like 911 dispatch. So 911 dispatch is going to say, it's going to be the responder. You call up 911, dispatch woman comes on the phone, you have a response unit. Dispatch calls out fire truck, ambulance, whatever needs to come to it. The observer in iOS, as I was talking about this morning, it follows the observer design pattern. Observer says, okay, what do we got? It's a text field. The person typed in there. First responder is the keyboard. Keyboard comes up so that the user can type something in. We're going to resign the first responder, which means, okay, we're done. Send the first responder away. It doesn't really matter what it is. If it's, well, I can't really think of any other examples. It's used mostly with the keyboard. If you type into a text field, I don't know, you have other actions that occur when the user interacts with other objects, and you have that first responder. First responder, 90% of the time, is the keyboard. It could also be something else. It could be like, for example, you decided to call somebody, and the call functionality came up, or the text messaging program came up, or the address book came up. You can get rid of the address book, get rid of the call, get rid of the text messaging. It resigned whatever responded to whatever action the observer said to go do. So what we're going to do here is on the input done, we're going to call the method to reverse the string and resign the first responder. So we already put the string in there, so I'm going to cut and paste this here. Copy, paste this here. Stick it inside of the implementation of this finish method. I called it something different than a tutorial, doesn't really matter. I'm going to paste it in here. And then I'm going to fix the pasting errors. Because we don't have output. What did I call it? Out text. So it was called out text. There we go. Out text is going to be, in fact, let me get rid of this guy over here. Here, let me just do this with it. There we go. And I got to put some lines at the bottom to move it up. Here we go. Move it up so you guys can see it at the bottom of the screen there. And self.output text, that's the label that I put out there. It's going to be equal to an NS string object. And the NS string is going to be this method here that we created, the string by reverse string, which is going to be the sender text. Well, the sender text is the text that's in, I'm going to put that down there for a second. The text that is in the the text that was created by the first responder is created by the GUI element that we just resigned. So we had a text box, we typed some text in there. That's the text from the sender. The guy who's sending this is the text box. He's sending I'm done return key signal that's triggering this finish method that's on the did end on exit. I ended, I'm done with this because I got the done. Here's your method call. String by reverse string. We're sending the method to the NS string that we're creating that's going to be equal to the out text.string. So we're actually running the method on an object. The object we're running it on is NS string. We're complementing the NS string behavior, so the NS string knows about this is a class method. This is a class we're running it on. It's not an instance of an object that we created from this class, it's the class. So, long story short, we're running a class method. Just like in Java or C++, when you have a class called person, and inside person you have a print, and you have person, my person, person, another person, and then you just have person.print. Put the class name in there, run a class method from the class, but not from any instances that are created from the class. We're running it from a class, and the class we're running it from is the class we added the method to. So from string, we're running string by reverse string. String by reverse string is this string up here that we put in here. String by reverse string is that method we added. So it's a class method run from a class and a string. So let's go back, because I think I had an error message in there. Let's go back to the M file. Oops. Did I put this in the wrong one? I put it in, no, it's in here. What did I do here? Oh, yeah. I have two.
You have to write out text.
Yeah, I got it. For method, because I have this, this one says .m and this one's highlighted .h. Another problem I have with Xcode, going back to the, what did you call it? Clunky? No. Junky? Junky. Back to the junky interface. Notice how over on the left-hand side, viewController.h is highlighted, which might lead you to think that it's right here. It's really hidden. It's actually right here. And this window has the viewController.m file in it. The only reason why I know that, because out of sheer practice, I have memorized to look right here to know what file I'm actually in. It's junky. Alright, so let's go back and fix this one. I always have to make sure I'm in the right file, because I can't tell you how many times I've been in the wrong file, because the junky interface is leading me to believe I'm in a different file than I'm really in. So I've learned a new word today, junky. If I can remember it, junky. Alright, what are we doing here? This is stuff we've seen before. We're going to NSLog it. I'm going to show you the NSLog actually. The NSLog, you're going, NSLog, isn't that what we were looking at with the plain old console stuff? Yep. You can put NSLogs all you want all over here, and it doesn't show up in the GUI. It actually shows up in the console. Great way of debugging. So I'm going to see what the string is. So I'm going to make sure my output looks correct, and then I'm going to send the responder. I'm going to sender. The sender, which was the text box, I'm going to reassign that first responder. So I'm going to tell the observer to get rid of that keyboard. That's what I'm going to do. All right. So that's how we're doing that class method. So let's go back here and make sure. I probably have some more explanation going on in here. What do I got in here? What happens? The action method sets the output labels text property to the reverse contents. Okay. And it's using the reverse by string method that we just looked at. We added. After doing this, it's going to call the first responder and say, hey, resign you. It just dismisses the keyboard. Output should look like that, although that's the old screenshot of the old interface. Let's see what our output looks like. Run the sucker. in the background, when this method actually fires, oh, I made this really big, didn't I? So I clicked in there and I got my keyboard to come up. That's going to happen automatically. Type on the keyboard. Or I can just say, what do we want to reverse? What did you say? Quick tree?
Keyword.
That's the
Oh, quirky. Oh, geez. That's where it came from. That's not the real keyboard, is it? Is that the real keyboard? Yeah. All right, let's go back up here and type a word in here. I don't know. What do you want? What do you want to reverse?
Reverse.
I'm sorry.
Reverse.
Reverse. I'll put a capital R in here. Reverse. We didn't change the capital.
reverse the string.
Reverse the string. Press return. What does that say? Well, we kept the capitals in there for us. So did you see the keyboard go away? So nothing on the bottom here. And then now it's reverse. This is reverse the string. We didn't accommodate for the caps because we just loaded it all up into an array and pulled it all out of the array in the opposite order. Added it to another array and then converted it to a C string to a string and a string. And then you see this is the interesting part down here. You see down here, reverse the string gave us this string reverse, which is this NSLog. So we can add NSLog statements in here to troubleshoot what's in here. Only thing though is when you publish this thing, you want to take out the NSLogs. Because what are the NSLogs going to do? Nothing. They're not going to show them anything. Unless you had a terminal prompt opened up on the app, most people remove NSLogs out of there completely. They're little messages, little cookies you're leaving to yourself to say, hey, look, it made it this far. This is the string that got reversed. So technically, if I come back up here and I click on it, I can start it all over again. I can just say, hello world. And then I get hello world backwards. World, hello. I can play with this all day. So you can figure out what are those panadromes or whatever, spelled the same way backwards. Palindrome, yeah, that's what I'm thinking of. Is that the same thing? Is the word spelled the same way backwards? Say that word again.
Palindrome.
Palindrome. Palindrome.
Palindrome.
Palindrome.
P-A-L-I.
P-A-L-I. Palindrome.
Palin.
I'm terrible at this. Anyway, is that what I'm talking about? Is this the same word spelled both ways? Looks the same? Yeah.
Madam.
Or dog? Or madam? Let's see.
Race car.
What did you say?
Race car.
Race car, is that? Race car? No.
Without space.
Oh. You're right. It's a palindrome. What was the other one? Madam?
Madam and remember.
Remember? No. No.
Remember.
Madam. Madam. Excellent, that's enough. Actually, does Barbara look the same? No. Arbor, no. It's not the same. All right.
CB.
What?
CB.
Civic?
Yeah.
Civic is?
Yeah.
Oh my God, you're right.
Rotator.
And look, we have all of the different NSLogs. What did you say? Potato?
Rotator.
Rotator? Let's see. Rotator. You're right. You can test it using this program. Alright. It's about all I can give you on this program. But let me show you another example though. Let me close this out real quick. Do I hear someone coming down the hallway?
Yeah, I can send.
Let me pause this for a second there. Let me stop this video. Actually, no, there's one more piece I want to show you that goes along with the same concept. So as we're waiting for the attendance person, I don't know. Anyway, long story short, let me shut this down. And let's make sure we got the right program output. We do. There's a little bit of summary to this. Let me go through the summary. Categories are very useful. They're very powerful tools, writing functionality to existing classes. Remember, it can be used for many different purposes. We have built-in categories. I'm going to show you one that's called math in a few minutes. In Java, we import the math. We go math.something. And we run class methods from math to do division and I don't know, powers and all the other stuff we're going to use inside of math. Same thing happens with Objective-C. I'm going to show you that next, which is that little piece I want to make sure I show you, because it goes along with the same lecture. But categories, just to sum up the concept, we've added a category to a class. All of the child classes of that class will inherit the added methods as well. Once you put it in somewhere in the hierarchy, it extends to the rest of the hierarchy, no problem, as further exercise. You could try to add another method to the NSString class category, build it up, define, replaces maybe all the strings with underscores or something else. Or maybe takes the caps and turns them into lower cases instead of upper cases. So, good timing. Let me pause this one here. All right, so that's your explanation. What I want to do is I want to show you the math one that's equivalent to what you see in Java with the math classes. So this one is actually, again, like the example I just showed you, it's kind of like next week's or next weekend's material. So this one is really in programming practice number 4. I'm not going to cover everything in number 4. I just want to show you the one here. So if you download code number 4, you unzip it, you get code 4. Inside of code 4, you get one that says category on it. If you open up this one, actually, if you want to see what we're going to do next time, you can look through the other ones. But we're going to finish 3 and get into more of 4 stuff as well. This is a category example. So this category is given for us outside. We didn't make this category. It's given for us in the language. So if I look at fraction.h, I see this. Before, when we created our category, we had NSString, and then we put added methods to string, or whatever we called that thing, added methods or something. And it ended up in this opening and this closing kind of bracket kind of thing. That's the use of the category. And we put that inside, well, we didn't actually, we implemented NSString, so as long as we had an NSString, we added the string with this string to the NSString, and so we just used it with NSString. Here we're not creating it. Instead, we're just going to use it. So we just use it this way, and it's already built in. So this is equivalent to taking math dot square root, math dot, and then with the capital N that you get from a class level. And what are we going to do? We're going to implement, we're going to override the add, the multiply, the divide, and the subtraction. So we have a fraction, and then we have we just have a fraction in here. Fraction math, which is going to give us our implementation of our math functionality. So we have the it's the same thing we did before. So we have math that we're overriding. Classes, or the category is called fraction. It's using add, multiply, divide, and we have the fraction implementation of this, where instead of taking and adding 2 numbers together, we're going to add a numerator and a denominator. We're going to work with both parts of this fraction. We're going to customize it so that in fraction we're going to have a numerator, we're going to have a denominator, we're going to have a print method, we're going to have a set numerator, set denominator, yada yada, all the other stuff that we've seen before. And we have a numerator, denominator, integer. In the .m file, we're going to implement the overridden methods to set the numerator, set the denominator, print it out. Here's the print method here that prints out this one over this one. So in main, we are using the fraction math along with fraction, which is going to give us our category of our added functionality. And we're going to take it and we're going to create 3 fractions and then print 3 fractions out using the print method for, well, what are we going to do? We're going to initialize, we're going to allocate and initialize the numerator, denominator. So we got 1 over 3, 2 over 5, and I believe we're going to multiply them together. Fraction 1 multiplied with fraction 2. If we run it, we just don't get anything too spectacular. We get 1 over 3 times 2 over 5, which is equal to 2 over 15, which gives us our overridden behavior for math using a category, math, which is a more automated and a more typical way of using the category. I think it's better to create our own, add our own methods to it, but this is just an override of it. So we can take regular and we can apply it to any kind of application that we might have that might extend the concept. That was a really quick overview of this. Next time, I'm going to cover a little bit more in categories. We have a couple more category stuff, a couple more protocol stuff to do, ways of extending out the concept and using it a little bit more in a application or in a programming environment. And we're going to look at private dictionary, ID, arrays, a bunch of other miscellaneous concepts as well. And also the use of these constructors, as I mentioned before. So we'll create constructors that are kind of not triggered automatically, but called, that do our initialization and our allocation inside. So we'll create a kind of constructor behavior. So what I'm trying to do is wrap this up and get us out within the next 10 minutes or so, because I think we can do that. Because I pretty much ran, unless I get into another big old topic, I'm going to end up starting halfway, and then 2 months later you're going to show up not going to remember exactly where I ended up anyway. So long story short, you got homework to do between now and next time I see you. So what do you got to do? Well, if I go back up here, you got to show up again on November 23rd, November 24th. So this is September 21st, 22nd, practically the same timing. We got this is September, we got October, the entire month of October, and the entire month of November. That's like 2 months. So if you don't do anything in the next 2 months, you're going to be kind of in sad shape, because it's going to be harder for you. So go out, get together with a bunch of friends, buy a Mac computer, share it amongst yourselves. Just buy one computer for the whole class and just rotate it around. But in the next 2 months, you might actually get 1 week for you, 1 week for you, 1 week for you. That might actually work.
Nobody lives close by, so.
Nobody lives close. These guys live close by. No? Oh. All right, shipping and handling fees and expenses. So, or do the Mac Mini thing for $300, $200. Find a monitor to work with or something. Anyway, long story short, see if you can crank out assignments number 1, 2, 3-ish, 4-ish. The last one you might want to wait on. Second to the last one, you probably, this one's the tough one. Number 4 is the hard one, actually. Number 4 is that parking meter and the parking car and all that other stuff. That one's going to take some time to do. This one here, you're going to need that Mac computer for. So you can do them in any order you want. The first one is really the easiest one. Crank out these guys if you can. That's my suggestion is to do that. But before you can do that, you need to get up to speed. If you're not up to speed, go to your free books, download some PDFs. And like I say, it's competency based. I'm not going to tell you you have to read this chapter, you have to do that chapter, or anything like that. You have to read whatever it is that you're going to need to read to get up to speed, to get figured out. Get your development system set up. If you have a development system set up and you can bring it to class with you in November, you'll have a lot more fun because we'll be able to create apps after apps, and you'll actually be able to do this stuff. And we're going to do some more advanced things that are going to be a lot more fun, actually. And read ahead. Read as much as you can to catch up on the concepts I've covered. I've covered everything up through inheritance. You can come back and look at what we covered. This is the section for this class. If you're so excited about it and you really want to learn it and you didn't have the equipment with you this time and you have nothing better to do on October 12th and 13th, you could show up again if you wanted to, completely optional, not part of the class. I'm teaching the same course over again. We're going to have the repeat of the same weekend with another group of students downstairs in room 102 probably. If you have problems, you have questions, you don't have to spend the whole day. You just stop in for a half hour. Say, hey, can you look at this? Is this what you wanted? Does this look right? Or you can say, hey, I don't understand. What in the world did you say about protocols? All that stuff. You don't have to do protocols actually in any of those assignments. Or you built this killer app and you want to show it off. You can bring it in, you can show it to me. Long story short, we will pick up where we left off. This is only the first weekend. We have another weekend of this. That's going to happen in November. The more prepared you are at that point, the more you're going to get out of that weekend, because we're going to hit and do maybe about a dozen apps that weekend. So it's going to be app after app. And it's going to be boring unless you can do it on your own. All the stuff we do in class you can reuse for your assignments. So you might find something helpful in there that you can reuse and stuff like that.
How about the final exam? How it's going to be?
Final exam is going to be pencil and paper. No computer needed for the final exam. It's going to be on Sunday, the last Sunday of the course at 3 o'clock in the afternoon. I don't set that, the university sets that. It's going to be multiple choice.
How long?
How long?
It's on December 22nd.
Well, you know, they make us do it for like 2 hours, but it's going to take an hour and a half, maybe. Hour. I don't know yet. I haven't written it yet. And actually now, like my current email that I was looking at today, looks like I have to have multiple copies of it. But this is such a small group. I'm just going to make one copy for you guys, one version of it. But they want like all the classes to have multiple versions of the exam. Anyway, long story short, it'll be easy. It'll be doable. It won't be too challenging. You won't have to write any source code. You'll have some source code given to you. Like if I gave you a method call and I asked you, what is this doing? It's sending the text. It's getting the text from this box or something, or it's doing that, and it's multiple choice. So it's like A, it's printing to the screen. B, it's getting input from the screen. D, concept related. How to do a method. How to how to do different things that we're talking about essentially. Unless we have any questions, discrete, because we're such a small group. Here, let me stop this video.